In this video, I introduce representation learning in artificial intelligence. The performance of our machine learning algorithms strongly depends on successful extraction of data representation. Deep architectures can lead to object representations because more abstract concepts can often be constructed in terms of less abstract ones. Deep learning learns from multi-levels of representation or a hierarchy of features. The capability of machine learning is determined by number of possible passes from input data to output nodes, besides using large-scale training datasets, as shown here as representation learning by using autoencoder, this latent code, this input, and this reconstruction. This contrasts representation learning with shared latent space of images and their captions. Rich interaction of many sources can complicate machine learning tasks. Representation learning disangles the factors of data variation so that the factors of the data tends to change independently of each other in the input distribution, and only a few at a time tend to change when considering a sequence of consecutive real-world inputs. Complex data arises from rich interaction of many sources, namely the factors of variation are entangled in input distribution. Representation learning is to disentangle many distinct but informative factors in the data. For example, pooling and subsampling layers in neural convolutional networks extract low-level information to form high-level invariant features, which are applied for object classifications or object recognition. The disentangled representations do not vary with minor changes in input data distributions. Unfortunately, it's often difficult to determine a prior which set of features will ultimately be relevant to the task at hand. Autoencoders and contrast representation learning models are possible solutions to extract the factors of variation. The information loss in the pooling and subsampling operations is represented by the overlapping features in the same layer, as shown here and here. The structure has a potential to learn a redundant set of invariant features to avoid significant loss of information. For more details, please check with these references. Thank you. Bye.